Hello everyone, today we are going to implement a simple neural network in Python. A neural network is loosely based on how the human brain works. Many neurons connected to the other neurons passing the information through their connection and firing when the input to a neuron surpasses a certain threshold. So this neural network, like the all neural networks, will have to learn what the important features are in the data to produce the output. In particular, this neural network will be given an input matrix with the six samples 010, 011, 000, 100, 111, and 101, each with three features column consisting of solely zeros and ones. For example, one sample in this training set is 010 would have the output equal to 0 and 101 with the output equal to 1. So the output is determined by the number in the first feature column of this data samples. So before getting started, we will need to import the necessary libraries. Only two libraries will be needed for this example. So the first one is Numpy. Numpy is a Python math library mainly used for the linear algebra applications. And the second one is matplotlib. It is a visualization tool that we will use to create a plot to display how our error decreases over the time. So as mentioned earlier, neural network need data to learn from. So we will create our input matrix and the corresponding output matrix using np.array. So this is our input array 010, 011, 000, 100, 111, and 101. And the output array is 00011 and 1. Now we will check an object-oriented approach to build this particular neural network. We can begin by creating a class called neural network and by defining the init function. This function will take the input and outputs as an arguments. We will also need to define our weights, which for simplicity we have started each weight being 0.50, because the each feature and the data must be connected to the hidden layers. We will need a weight for the each feature and the data. So for the plotting purpose, we will also create two empty lists, loss history and the iteration list. This will keep track of our neural network error at each iteration during the training class. So this neural network will be using the sigmoid function as the activation function. The sigmoid function is a popular nonlinear activation function that has a range of 0 to 1. So here we have the sigmoid function. So the next step and then creating new simple neural network as the forward propagation. So for forward propagation, we will simply define the self dot hidden equal to self dot sigmoid, and then we will going to the backward propagation through the neural network to the update the weights. This is the coolest part of the whole neural network. Big propagation will go back through the layers of the neural network, determining which weight contributed to the output and the error. Then change the weight based on the gradient of the hidden layer's output. This will be explained further. So here we have self error, which is equal to the predicted output minus the estimated output minus the predicted output, and then we will calculate the delta variable, which is equal to the error multiplied by the sigmoid function. After that, we will update the each weights and the hidden layers. So the next step is to train the neural network. So for training the neural network, we can begin to make the predictions, and this the prediction function will look similar to the hidden layer or the feed forward function. And for this we will use the 25,000 iteration, and we will flow forward and produce an output and then go back through the neural network to make the correction based on the output. And then we will keep track of the error history to over the each iteration to plot. After that, we will use a function to predict the output on new and the unseen input data. So we will create a neural network and an equal to neural network inputs and outputs, and then we will train the network using nn.train. We will use the two new example, which is 110 and 011. So we will now run the code. So here we have the outputs of the 110 and 011. For 110, the predicted output is 0.99 while the correct output is 1. And for the example number 2, 011, the predicted output is 0.006, which is nearly equal to 0 while the correct output is equal to 0. And the error is shown in the plot. We can see that the error was nearly equal to zero point 0.5 uh, in the first iteration, while on 15,000 iteration the error is 0.10, and then using the other iteration the error has been decreases to 0.05. Thank you.